Okay, guys, today we're gonna go through the algorithm for um, getting the minimum spanning tree in a graph. And that algorithm, the first one which we're gonna go through, is the Prim's algorithm. Now, there are two types of algorithms which do this job, that is, finding the minimum spanning tree. The first one is the Prim's algorithm, and the second one is the Kruskal's algorithm. Now, firstly, we're gonna go through the Prim's algorithm, and that is based on the node method, which is you start with one node, you calculate the least edge which is connected to that node, and you visit the node which is connected to that one. Okay, and then when that happens, you mark both of those nodes as visited, and then check the smallest edge which is connected to either of those nodes, and then you mark that other node as visited too. So let us go through the algorithm. I'm gonna write this code in Java as always. So first we need a scanner class to be imported. So we go import java dot util dot scanner with the s capital, then we go scan static scanner scan, and then we make the public, that is the main function, public static void main string args, and inside there I'm going to initialize the scanner object is equal to new scanner system dot in. So this is going to be the object which takes the input from the user. This is like you're seeing in C++ and scanf in C. So okay, so there are a few things you need in order to begin this. First thing we need is the matrix, obviously. So we go int matrix equal to new int. Now here we are considering 5 nodes, so we'll consider 5 bidimensional matrix which has 5 nodes in each row and column respectively. So next we need a visited array to keep track of all the nodes we have visited, equal to new int 5. Next we need a minimum variable which will store the value of the minimum value basically in the array, from the array. Then we need u int u which is initialized to 0, and int v which is initialized to 0. Now these will be the variables which will store the the u and v variables will store the coordinates of the nodes, which we'll get to later. And then we need int total, which will store the total value basically of whatever we calculate. Now we can proceed to taking the inputs from the user. So we go for int I equal to 0, I less than 5, I plus plus, and then we go for, because this is a two-dimensional array, we need 2 nested for loops. So int I equal to 0, I less j less than 5, and j plus plus. Okay, so we go through this, and then we ask the user for the input. So we go matrix I and j is equal to scan dot next int. So this will be basically taking inputs from the user. Basically integer variables from the user. We can do one more thing, that is initialize the visited array to 0, because none of them are visited right now. And then what we do is if this is visited, basically what happens is that in the matrix, if the values are 0, we have to replace them with 999 or infinity, but we cannot do that. We cannot replace the values with infinity because there is no infinity in computer language. So we replace the zeros by 999. So we go if matrix I and j is equal to 0. What you do is matrix I and j is equal to 999. As simple as that. Now we'll actually start the algorithm. So the first thing you want to do is the source, the vertex from where you are starting, you need to mark that as 1. The visited array of that vertex is 1. So basically I'm going to start from the 0th vertex, so I'm going to mark that as visited. So visited 0 is equal to 1. So basically we need for loops, like we need to execute this piece of code 4 times. So what I'm going to do is I'm going to make a for loop. Counter is equal to 0, counter less than 4, and counter plus plus. Now why am I executing these 4 times? Only because I have 5 nodes, and a minimum spanning tree with 5 nodes is going to have a spanning tree with 4 edges. As simple as that. If you don't believe me, you can draw a 5 noded graph, and actually figure it out for yourself. It's not that difficult. Okay, the next thing I'm going to do is initialize min to 999, because you'll see later on why I'm doing this. You understand it. Actually, I don't even need to initialize this over here. It will initialize itself over here anyway. So we go min equal to 555. Oh, sorry, 999. So basically how this algorithm works is I'm going to go through all the visited nodes in the matrix, and I'm going to check if the edges which are connected to it have the minimum values, and the one which has the minimum value, I'm going to take that node and mark it as visited, and then repeat the whole step exactly 4 times, because 4 is the number of edges we're going to have, a period. Yeah, so I'm going to do a for loop. So for int I equal to 0, I less than 5, I plus plus, and then I'm going to check if visited of I is equal to 1, and only then, if the I is visited. What happened here? Okay, sorry guys, I think I missed a bracket over here, but that's just that's okay. We can replace it. You'll know what to do. So next, when we here in the for loop, we're gonna check. We're gonna go through all the visited array, and we're gonna check if I is equal to 1, if that node is visited. So what we're gonna do, the first node, that is the 0th node, is visited. So we're gonna go through that and check if either of the edges is the smallest. So we're gonna go for int j is equal to 0, j less than 5, and j plus plus. Now we got the next node is visited. Okay, so we need to check if the one which is connected to the ith node, which is the jth node, is visited. If is not visited, so we're gonna go if visited of j is not equal to 1, and only if it's not equal to 1 is we're gonna run this piece of code. So we're gonna go if min is greater than matrix of I and j, if the minimum value is greater than the matrix. And what is the minimum value? 999. If that is greater than the current value of the matrix I comma j, we're gonna exchange these values. So we're gonna go Control C, Control V, and we're gonna replace this by equal to, and a semicolon over here. And then the funny part, u is equal to I and v is equal to j. So what happened here? You're giving the value of I to u and the value of j to v. Okay, so I'm gonna stop over here and continue this in the next tutorial. Thank you for watching. I hope you understand Prim's algorithm. It's very simple actually. So see you in the next episode, I guess. Thank you.